Sheet number 3, we're going to deal with polynomials. Poly meaning many, nomials, many terms. We have to be proficient. We're going to start off with adding and subtracting terms. We have a binomial, two terms, adding two terms. And we have parentheses, so we can't combine these two terms yet, even though they're like terms, but we're not able to combine them until we distribute this addition sign. There's an invisible 1 outside there, so it's 1 times 2x and 1 times -9. And we understand that when we multiply by 1, it's not going to change the term, so technically our next step is here. And we're adding these two. So now parentheses are gone, so we can do 5x when we have like terms. Like terms have the same variable to the same exponent, and we combine their coefficients. So we're going to combine 3 and 2 to make 5x, and then we're going to combine the constants where we have a +4 and a -9, which is -5. The other way that you will see this introduced is we will take the binomial and add the binomial, and we will see this in column form where we align these like terms. They are like because they have the same variable, so we will combine their coefficients. So this is a similar way that you see it being taught, where you get 5x minus 5. So we're going to line those up. Either method's fine. You're going to see when it's subtraction, I'm going to use the distributive because that's a whole lot easier and less likely to make those silly mistakes. And it's a little bit harder using the column form when we distribute. So we're going to write -8x squared minus 3xy plus 9. -1 times 2xy is -2xy, and -1 times 3x squared is -3x squared. Now notice it says not only operate, which means simplify, never heard of that word operate, and then write your answers in standard form. Thank goodness I have been a stickler already and introduced you to what the expectations of standard form are. So first, we're looking for like terms. We have x squared and x squared, so we're going to combine their coefficients. -8 and -3 makes -11x squared. Then we have the like terms of xy and xy, so those coefficients give you -5xy, and then we have that leftover constant, don't forget it, plus 9. So that's the nice way of doing that. I'm not going to go through the column, but you already see one of the issues about using column is this is not in standard form, so we would have to align it, and then we would have to know that we're subtracting from the bottom from the top. So it's really less benefits using the column system than the distribute and simplify and then combine like terms. So when we distribute that, that's not going to change any of these terms because anything times 1 is that original. So we're going to put it in a line without, minus 3t squared plus 8t cubed. We notice that that's not in standard form. So we're going to align. That gives me 13t cubed. We have t squared and t squared. That's going to give me -t squared. We would never write -1. And then we have the constants. -11 and -5 makes -16. So we'd never write -1 in front of a coefficient. Remember that little tip. We're going to distribute the -1 in there. So we'll rewrite without the parentheses 9x to the 4th plus 6x minus 7 minus 7x to the 4th plus 2x minus 9. Changing the sign. When you multiply everything by -1, it changes each of those individual signs. So let's look at like terms. X to the fourth gives me 2x to the fourth. We have 6x, 2x, which gives me 8x. And then we have -7, -9, which is -16. So we should get 2x to the fourth plus 8x minus 16. Making sure that that is in standard form. X to the fourth, x to the first, no variable. We're going to do it in alphabetical order. And if we tie in the letter, then we are going to do it in power. Exponent will determine its place. Bigger power comes before. All right, now we're done with adding and subtracting polynomials. Now we're going to multiply polynomials. So we have a monomial times a binomial. And just like Halloween, which it's this time of year, we're going to distribute candies and fun things. So we have 2x times x squared plus 2x times 3. We distribute that 2x times into each of the terms. So we have the 2x that we're distributing, and we're distributing it to the two terms, x squared and 3. So we see that we distributed the 2x to both of the terms, x squared and 3, and now we're multiplying, and we're going to multiply 2x times x squared, which gives us 2x to the third. When we have like bases and we multiply, we're going to add their exponents. 1 plus 2 is 3, and then we're going to multiply their coefficients. 2 times 1 is 2. So when we have this, we have coefficients 2 and 3, which is 6, and then we have the variable that has no pairing. So this is in standard form. We cannot combine these two. That's my answer, because those are unlike terms. So that would be the solution. Now we have a monomial times a trinomial. Trinomial meaning 3 terms. We're going to take the monomial and distribute it out to each 3. -5y squared times 7y cubed minus 5y squared times -3y minus 5y squared times 10. We are distributing a -5y. And now we are going to multiply each of these pairs, because multiplication comes before addition and subtraction. So we're going to look at their coefficients. -5 and -7 multiplied makes -35. Y squared times y cubed, we're going to add their exponents, produces y to the 5th. -5, -3 multiplied makes +15. Y squared times y, remember there's a 1 there, gives us y to the 3rd. And -5 times 10 is -50 y squared. So we should get -35 y to the 5th plus 15 y to the 3rd minus 50 y squared. All right, here we go. This is a binomial times a binomial. We will use FOIL to help us. F is first, outer, inner, and last. Last. That's what FOIL. So firsts are the first in each of the binomials. First times first. Outer is going to be the outside 2. So we have the outside 2 terms. X times 3. -3, excuse me. X times -3. Then we have the inners. And those are the inner 2 terms. 4 times x. And then we have the lasts. And those are the last 2 terms. So the lasts in each of the binomials. And that would be 4 times negative 3. So if we do that again, it looks like this. X times x plus x times negative 3. Let's move this. Plus 4 times x plus 4 times negative 3. So we see that this is our firsts, x times x. The next distribution would be our outsides, our insides, and our lasts. And now let's do each of those products. X times x is x squared. X times negative 3 is negative 3x. 4 times x is 4x. And 4 times negative 3 is negative 12. We're not done. We have like terms here as our inside and outside, or outside and inside. So we can combine those. So simplified looks like that. Now, I'm going to be honest with you. You should not have to do that much work. You should be able to look at that problem and tell me what the solution is. I'll make up one. X minus 7 times the quantity x plus 3. So we know that's x squared minus 4x minus 21. You should be able to do that fast. X squared. We see that that is going to be, right, we have our inside and our outside. Negative 7x, positive 3x gives us negative 4x. And then we have negative 7 times 3 is negative 21. You need to be able to do this process 100 times, and then you'd be able to do that process that fast. You should be able to take any, oh, and then it gets even better when you have 2x minus 5 and 6x plus 7. Ooh, that's a tough one. Let's do that one. So you're going to get 12x squared. You got 12 and negative 35, which gives us negative 23x. I think so. And then minus 35. That's easy. Your outside and insides, your outside and insides make this. This is your firsts, this is your last, and this is your outside plus your inside. Always, always, every single time. So I know that's a little bit of an aside, but so we should be able to look at that. 2x times x squared plus 2x times negative 3 minus 1 times x squared minus 1 times negative 3. It's a double distribution. That's the other way I teach this, is it's a double distribution. If we look at this, yep, I know. If we look at 2x that we are distributing, think about it, we're distributing the 2x to both of the terms in the other binomial. And then we're distributing the negative 1 to both of the terms in the other binomial. So the way I have described it sometimes and taught it is it's a double distribution. That's not a bad way of looking at it. So now let's simplify. 2x times x squared gives you 2x to the third. 2x to the third minus 6x minus x squared plus 3. Now a lot of students would stop and give that as their answer, but this is not in standard form. X to the third, x to the second, x to the first, and no x. So make sure that your answer is in standard form, or else it's going to be considered incorrect. This is a tricky one. This is a mistake that most students make in 8th grade, is they distribute the square into addition. You cannot distribute into the parentheses when it's addition and subtraction. You cannot. So you need to be able to understand that this is this. This is the exponent. The exponent is 2. What's the base of the exponents? This is the base of the exponent. So we have 2 of these. And then we're multiplying. And now we do the double distribution or the FOIL, however you want to distribute, and multiply those 2 binomials. You get, well, let's write it out. You get 4x times 4x plus 4x times 3 plus 3 times 4x plus 3 times 3. This is called a binomial square. This is a binomial square. So this gives us 16x squared plus 12x plus 12x plus 9. And you'll notice that my outside and inside are identical. So 16x squared plus 24x plus 9 would be our final answer. A binomial square has a pattern. So a binomial square, let's get into this. Binomial square looks like this, a plus b quantity squared. And our solution is always going to be a squared plus 2ab plus b squared. If we wrote this out as a plus b times a plus b, we'd have a times a plus a times b plus b times a plus b times b. A squared plus ab plus ab plus b squared, or a squared plus 2ab plus b squared. Notice those are the same things. So if we can use this template, this is the binomial square template. I can use this as a bit of a cheat sheet. And so this cheat sheet can be used under any circumstance that I have. The circumstance can be, oh, what if I have 3x plus, no, let's not use 6, let's use 5y, quantity square. So this represents my a value. This is my a value. This is my b value. So if we know that a binomial square is going to produce a squared plus 2ab plus b squared, my a value is 3x, quantity squared, plus 2 times my a value times my b value plus my b value squared. And we'll show. Let's show how it's done. This is my a, right? This is my a value, so I'm going to plug in the a value. This is my a value, I plug in my a value. This is my b value, and this is my b. So here's my b for here, and this is my b being squared here. I guess I could draw that too, that'll help. So it's 2 times a times b. So now we can just simplify it. 3x quantity squared gives me, come on back, gives me 9x squared. And then if we multiply 2 times 3x times 5, 2 times 3 is 6, times 5 is 30xy, and 5y quantity squared is 25y squared. So that's how we can easily multiply quantity 3x plus 5y quantity squared using that template. It's an easy, quick way. It's an algorithm to help you with a shortcut. Much like you should be able to do these real quick by eye, meaning you should be able to multiply those 2 binomials really quickly. You should also be able to do binomial squares really quickly. You should not have to write any of this down. Cubes are also, so especially this one, but you know, look, let's be honest, maybe in high school you'll have memorized it enough, but we're going to multiply these two. We should be able to multiply that That produces that. That one you should know. And then we're going to distribute. The crazy part of this is we have 3 independent things. We're going to take this and distribute it into the 2 terms. We're going to take this term and we're going to distribute it into the binomial. And this time, because this is a trinomial times a binomial, we're going to distribute that into both of the terms. So not as easy, but you will see a pattern and you will memorize what the quantity of x plus 1 cubed is. So we have x squared times x plus x squared times 1 plus 2x times x plus 2x times 1 plus 1 times x plus 1 times 1. X to the third plus x squared plus 2x squared plus 2x plus x plus 1. And we have some like terms here. We have 2 places. We have like terms here and here. So this simplifies to x to the third plus 3x squared plus 3x plus 1. And you will notice that that also will be a fun, and you can substitute A and B, and you can create a template very much like this that you can apply to every trinomial, or no, binomial cubed, excuse me. There's a binomial cubed. So that will also fit. These, notice these are almost the same, but different second terms. And we call these conjugates. Conjugates come into play not only with polynomials, but also with radicals, especially radicals that need to be rationalized. Oh, we'll get to that. So when we distribute, you have k times k plus k times negative 5 plus 5 times k plus 5 times 5. That's the double distribute. K times negative 5, 5 times k, 5 times negative 5. We get k squared minus 5k plus 5k plus 20. Oh, forgot the negative, sorry. Minus 25. And what do we notice about the outside and the inside? The outside and inside, because they're conjugates, are outside and inside. Because they are conjugates, the opposite of each other, they're going to cancel. Our inside, our middle term cancels, and we're left with k squared minus 25. And we call this the difference of squares, because both are perfect squares. So multiplying conjugates produces the difference of squares. And this one you should be able to do super quick. If we have a plus 7, a minus 7, you're going to get a squared minus 49. It's as fast as that, because we already know our outside and inside are going to be opposites of each other. 7a and negative 7a, they're going to cancel. So we will not have a middle term. This will be a binomial. It will produce the difference, subtraction, of 2 squares. A squared is a perfect square, 49 is a perfect square. So multiplying conjugates produces a binomial that is the difference of 2 squares. Oh, these are conjugates. So all we need to do is multiply the first and the last, because the inside and outsides will cancel. 7t times 7t is 49t squared. Negative 11 times 11 is negative 121. As fast as that. And when you're doing the academic decathlon, it is about time. It is about being efficient. It is about recognizing things, attention to details, recognition, and knowing the shortcuts. And not shortcuts in not doing work, but shortcuts in the sense of recognizing the most efficient way with some of these problems. Some of them, there's some heavy lifting. Some of them, like these problems, you should be able to do super quick. Now, these are conjugates because they're opposite of each other. But one of the things we have to make sure is that our answer is in standard form. So we get 25 minus x squared. That's how fast we can do it. Inside and outside are still going to cancel because they're conjugates, but we would need to write it like that. So just make sure that you put it in standard form, meaning the variables come before the constants, and don't forget that negative with the x squared. These are conjugates. Ooh, x to the fourth minus 4, as fast as that. X squared times x squared, like bases. When we multiply like bases, we add their exponents. 2 plus 2 is 4, and 2 times negative 2 is negative 4. That's nice and easy. Prerequisite skills, collecting like terms. So, like terms, like terms, like terms. They have the same term, x to the first, y to the first. So we are going to combine their coefficients. 2, 3, and negative 7 gives us negative 2xy. That's nice. That was not that challenging. All right, now, like terms, combine their coefficients. Negative 5 and positive 2, negative 3x, negative 3 and positive 1, negative 2x squared. But make sure it's in standard form. So it's that little teeny add-on step. Are you paying attention to the details? Like terms, like terms. Oh, I like this one. This is the first time. So you get 7t. Well, let's do it. Mr. Mac cheated in a way. Y, we would probably add the y's first. You get y. We wouldn't write a 1y. We would just write y plus 7t. Now, standard form. This is not in standard form. We have to put the 7t in front of the y. Not because of the 7, because t comes before y. Alphabetical order. Alpha order. And like in this case, we have the same alphabet, same letter. We have to go with the larger exponent. So we don't have that in this, but then we do exponent as the next tie. If they have the same alphabet, they have the same letter, then we're going to put it in descending order from the biggest exponent down to the smallest exponent. So one of the other things is if we have 3x minus 7z to the third, is that in standard form? Yes. Even though this is to the third, x comes before z. So this is going to come before z to the third because it's alphabetical first. X comes before z. Got it? Good. I think that's it. Very nice. Good luck.